Hello. Now we're really going to be looking at our notes for section 7.2 today. So on your learning target sheet, let's take a look and see what we're really going to be doing today and learning about today. So the first thing is we looked at direct and inverse variation and writing those inverse variation equations last time. So today we're really going to be graphing. We're going to graph some simple rational functions, and then we're going to look at translations. And I've told you we're going to do these transformations a lot of times, so here's another time that we're going to do that. So these are both in this 7.2 section. We're going to be really graphing today. So in your notebook, we really are just going to be using this one sheet here that's going to have all of our information. So let's go ahead and start with the most simple parent function, right? And we always want to start with the parent function and then deal with our transformations from there. So graphing the parent function. This is what my parent function looks like, okay? 1 over x. That's really our inverse variation, right? And this is our constant variation. The way I can just graph this is I know that it's going to look kind of like this. One way we can always do this is plug in some values for x, right? Just plug in some to the right of where you know and to the left of where you know and then plot them. But this is what our parent function looks like. The domain I know is x cannot equal 0. And I know that because if I'm dividing by 0, we just know mathematically we can't do that. So my domain, we can write it as x does not equal 0. My range, right, and my range is all of my possible y values, my range also cannot be 0. So those things create my horizontal and my vertical asymptote. And remember that an asymptote is a line that our graph will approach infinitely close but never actually touch. So for my parent function, I have a vertical asymptote at x equals 0, and I have my horizontal asymptote at y equals 0, and I know I can plug in the pieces from there. So here's our example. So now I'm asked to graph this f of x equals 4 over x. So my a value is 4, and so now I can just graph it. So since nothing is different than my parent function except that a, I know my asymptotes are still going to be on my axes at my x equals 0 and my y equals 0. So now that I have my asymptotes drawn, I always want to start there when I'm dealing with rational functions. Now I can pick some points to the left of my asymptote and to the right of my asymptote. So I just picked -1, -2, -3, and 1, 2, and 3. Then you can just plot those points, plug it in, come up with your y values, and then plot those points and kind of connect your curves. Okay, that's kind of the most simple way to do that, is picking some points and seeing what happens. So here you can see the difference. That 4, what it really does is kind of stretches that out a little bit further. So that's really where we're looking at. Okay, so now let's look at an h and k. And we've always known h and k were coming back to haunt us because they do every time. So they do the same thing. So again, h is going to be our horizontal translation, so back and forth, and k is still our vertical translation. So how do we actually do that? Let me get this a little bit more over here. Perfect. Okay, so here's just our general function, okay? So my asymptotes here have changed. So my asymptotes become my x equals h and my y equals k. So these two values will give us our asymptotes. And the way we can always know about this asymptote is whatever will make this 0, my x cannot be. Okay, so that's always going to help us too. So that's what becomes this asymptote, and then I can just plug in the rest of my graph. So now here's this example. So now I have -4 over x plus 2, and then -1. So first I come up with my asymptotes, so my y equals -1, so I graphed that in purple. And then whatever will make this 0, my denominator 0, or my h value, and my h value here would be a -2, so I go ahead and I mark that asymptote in pink. So now I know where I can pick some points. So I pick some points to the left of my asymptote and to the right of my asymptote. So here are just the points that I picked, and you can pick any points you want that are to the left and to the right. Come up with your y values and draw your curves. So one thing I noticed that's different between these two is the location of my curves. Okay, so here in my example, in this first example, just my normal function, I see that I have my curves up in this top right and the bottom left. But here in this example, I have them in my top left and my bottom right, so they've gone and changed places on me. So they were up here and now they're down here. That's what this negative sign right here does, is it kind of switches the location of where the points are. But if you just pick some points, that will that'll be pretty clear anyways of where you should go. Okay? So sometimes you'll be given a function that looks kind of like this. So I don't have my h and k. It's written as like a binomial over another binomial, and that happens too. So how can I graph that? So again, I always want to find my asymptotes first and go from there. But here I have to find different asymptotes. So to find my vertical asymptote, the one that goes up and down, I set my denominator equal to 0 and I solve. And that's going to tell me where my asymptote goes. My horizontal asymptote, so going side to side, I take just the values of my a and c, so the thing with those x's. And that's going to be just the equation of that line. Okay? So let's look at an actual example. So here I have f of x equals 2x plus 1 over x minus 3. So first I always find my asymptote. So my vertical asymptote, I set my denominator equal to 0, so it'll be at x equals 3, so I plot that line. My horizontal asymptote is I take the values of a and c, which would just be 2 over 1, which gives me 2, so I plot that line as well. So now I have that x value where I can pick some points to the right and pick some points to the left. So I picked 0, 1, and 2, and then I picked 4, 5, and 6, because this line is at 3. And so then I can see where my curves go, and I can connect them just like that. The other way we can do that is to actually rewrite that function that's in this form back into more of our standard form here where we can graph it. So that's kind of really what we're looking at here. So I want to rewrite it as this. Okay? So how I do that is we're just going to walk through this example. So I have my 3x plus 5 over x plus 1. So I could graph that just finding my vertical asymptote and then my horizontal asymptote, but I can also rewrite it into this form so I can find my h and k easily. So I go ahead and I perform my long division. So I've got my 3x plus 5 inside my box and my x plus 1. So I ask myself, how many times does x go into 3x? And that goes into it 3 times. 3 times 1 is 3, and 3 times x is 3x. Then I subtract going down, 5 minus 3 is 2. So how I can rewrite this is now I have my 2, my remainder that was down here, goes on, it becomes my numerator. The thing I divided by, my denominator, stays the same, and this is the remainder. So now I have my k and my h, so I can plot my 2 different places here, my 2 different asymptote lines, and then pick some points and graph as well. So either way you graph these two works, but sometimes it's a lot easier to get it into this form so you know exactly where your h and k are. Okay, so now we've graphed several different types of these rational functions. We've looked at the parent function, then we've looked at some translations, and now what do we do if we just have this big form? And we can rewrite it, okay? So that's really it for section 7.2, is being able to take all of these different things and use, and just graph it. So now it's time to go ahead and work on your homework and your practice problems, and let me know whenever you get stuck.